The paper of the day is highly available transactions, virtues and limitations. To minimize network latency and remain online during server failures and network partitions, many modern distributed data storage systems eschew transactional functionality, which provides strong semantic guarantees for groups of multiple operations over multiple data items. In this work, they consider the problem of providing highly available transactions, or HATs in short, that is, transactional guarantees that do not suffer unavailability during system partitions or incur high network latency. They introduce a taxonomy of highly available systems and analyze existing asset isolation and distributed data consistency guarantees to identify which can and cannot be achieved in HAT systems. This unifies the literature on weak transaction isolation, replica consistency, and highly available systems. They analytically and experimentally quantify the availability and performance benefits of HATs, often 2 to 3 orders of magnitudes over wide area networks, and discuss their necessary semantic compromises. Highly available transactions. This paper discusses isolation levels which can be achieved with high availability, that is, read committed isolation, variations of repeatable read, atomic reads, and many session guarantees, and with sticky availability, that is, read your own writes, RAM, and casual consistency. The section also discusses properties that cannot be provided in a HAT system, that is, those preventing lost updates and write skew or guaranteeing recency, such as repeatable reads, snapshot isolation, and serializability. Looking at evaluation, the paper uses TPCC benchmark to evaluate HAT. TPCC consists of 5 transactions capturing the operation of a wholesale warehouse, including sales, payments, and deliveries. 2 transactions, that is order status and stock level, are read-only and can be executed safely with HATs. Clients may read stale data, but this does not violate TPCC requirements, and clients will read their writes if they are sticky available. Their prototype database is a partially replicated, that is hash-based partition, key value backed by LevelDB, and implemented in Java using Apache Thrift. It supports eventual consistency, that is last writer wins, with standard all-to-all anti-entropy between replicas and the HAT MAV algorithm described earlier. The experiments compare these with a master based on HA solution. Here are some of the highlights of the paper. For me, the highlight was this specific diagram. It shows the relationship between common consistency models for concurrent systems. Arrows show the relationship between consistency models. For instance, strict serializable implies both serializability and linearizability. Linearizability implies sequential consistency, and so on. Colors show that how available each model is for a distributed system on an asynchronous network. Now, what's a consistency model? A consistency model is a set of histories. We use consistency models to define which histories are good or legal in a system. When we say a history violates serializability or is not serializable, what we mean is that the history is not in the set of serializable histories. We say that consistency model A implies model B if A is a subset of B. For example, linearizability implies sequential consistency because every history which is linearizable is also sequentially consistent. This allows us to relate consistency models in a hierarchy. Speaking informally, we refer to a smaller, more restrictive consistency models as a stronger and larger, more permissive consistency models as weaker. Not all consistency models are directly comparable. Often, 2 models allow different behavior, but neither contains the other. Finally, looking at the contributions of the paper, they relate that many previously proposed database isolation and data consistency models to the goal of high availability, which guarantees a response from each non-failing server in the presence of arbitrary network partitions between them. They classify which among the wide area of models are achievable with high availability, denoting them as highly available transactions. In doing so, they demonstrate that although many implementations of HAT semantics are not highly available, this is an artifact of the implementations rather than an inherent property of the semantics. Their investigation shows that besides serializability, snapshot isolation and repeatable read isolation are not HAT compliant, while most other isolation levels are achievable with high availability. They also demonstrate that many work replica consistency models from distributed systems are both HAT compliant and simultaneously achievable with several asset properties.